I'd like to welcome my colleague, Sydney Gladman, Chief Scientific Officer at the Material Innovation Initiative. And we've been hearing about a lot of different technologies today, and she is a material scientist and engineer, and she's going to come help us understand those technologies in some more depth. Thank you so much, Sydney.
Thanks, Nicole. It's great to be here. Happy to close out the day with a little bit of science and technology. So hopefully everyone's still awake. So I'm going to talk a little bit about the landscape of next-gen materials and the technology and scientific innovation that's going into this space. Hopefully you were able to see Elaine's presentation earlier today, which kind of covered the landscape of the industry, the investments, and the kind of trends we're seeing across the board. And this is going to dive a little bit more into the technology space. So first, a little bit about me. Like Nicole said, I'm the Chief Scientific Officer at MII. I'm a material scientist by training, and I'm very passionate about sustainable materials and processes, particularly those that rely on the resources and principles of nature. So biomimicry and bio-inspired materials are really my passion. I'm super excited to see all the presentations here today because little aspects of my academic and professional background have been coming out today. I actually did some tissue engineering, so seeing the lab-grown leather presentation from Vitro Labs is super, super exciting. I've done 3D printing, I've done lots of different things, so it's just awesome to see all the innovation that's going into this space. So you've heard a little bit today about what MII is. I'm just reminding everyone, in case you're new to the conference today, that we are a nonprofit working to accelerate the development of next-gen materials. And we call these animal-free, high-performance, and more sustainable materials. We do this by partnering with all the stakeholders in the industry. So everybody that's participating here today, scientists, brands, startups, investors, retailers, everybody who's really making this happen. And we provide resources in order for the industry to continue to grow and accelerate and be successful. So I'll talk about some of those resources soon. And really, we have a vision, and that vision is that the materials we interact with every day are produced in a way that allows animals, the planet, and future generations to thrive. So I said that one of the big things we do is we provide resources. I wanted to make sure to highlight a few of those. A few have already been mentioned in earlier sessions. For example, the State of the Industry report and the Brand Engagement report. Elaine covered in a lot of detail in her presentation. If you were there, definitely check those out. Those are your best, high-level overview of what's happening in this space, the really exciting progress that's been made to date. If you're looking for things that go deeper into some of the technical aspects of this work, I'd recommend our white space analysis report. I'll actually talk a little bit about that in a few slides. But it really goes into kind of the areas for opportunity, the challenges that we see in this industry that need directed attention in order to solve. And then lastly, I wanted to highlight, again, from the technical side, we have a report on silk called What Makes Silk Silk. And this is really supposed to be a guide for innovators. If you were interested to create a sustainable silk replacement, where would you start? You need to understand the incumbent material, silk's properties, and what progress has been made to date, what target properties you need to achieve. And this is the first of a series that we are producing here at MII. So we'll hit all of the material categories that MII looks at: leather, fur, wool, down, exotic skins, in addition to the silk that we've already published. So stay tuned for those. And I just wanted to remind you, sustainability is the name of the game here. I know a lot of people have seen some of these statistics, but this is just to remind you why we feel we have this need for next-gen materials. The environmental impact of textiles cannot be ignored. This is just two statistics showing kind of how global greenhouse gas emissions are attributed to the industry, as well as how water is really not being utilized effectively in the textile industry. And so we have a lot of room for improvement in making materials that have lower impacts on our planet. And this slide was already shown by Elaine, but this really captures how we at MII think about the challenge. So it's not just the environment, but we also have animals to think about. We have public health to think about. We have human rights in the workforce to think about. And so we feel that the next-gen materials industry is going to be the solution for all of these challenges. And again, to remind you, these are high-performance, animal-free alternatives to leather, silk, wool, down, fur, or exotic skins that help move us away from the animal-based and petroleum-based incumbents. And so let me talk a little bit more about that. I know Elaine covered a lot of definitions, but just as a reminder, the incumbents are those animal-derived materials. But we have this middle ground, what we call the current gen alternatives. And these tend to be our petroleum-based materials. For wool, we might have acrylic. For leather, we have polyurethane. There's been a lot of talk about polyurethane today, which I love to see. Each of our material sets have found a alternative to date, but we all know that these are not necessarily the long-term solution we should be planning for. We need to move further away to the next material economy, relying on truly high performance and sustainable inputs and processes. And that's what we're calling next-gen materials. So again, environmental impact is the name of the game. Just as a little bit of data to show you what we are encouraged by at MII in terms of how next-gen materials are really going to solve the environmental sustainability crisis we see in the textile industry. This data is being plotted from the Higg Index, Material Sustainability Index, or MSI. We actually have Joelle Mertens from the Sustainable Apparel Coalition, who created the Higg product tools, tomorrow. So if you have any questions about how the Higg Index works and where this data comes from, I encourage you to reach out to Joelle directly. But as you can see, we can plot a little bit of data for 3 different materials here. We've got the incumbent material, or cow leather, the current gen alternative, which would be polyurethane leather, and we have a next gen material, a plant-based leather called Pinatex. And you can see across the board, depending on which environmental impact category you are considering, Pinatex typically has much lower environmental footprint compared to cow leather, and in most cases also compared to the polyurethane leather. Now, I want to mention that this is really promising, and this is the kind of data we need to see in order to have the stakeholders in the industry be able to make decisions. But we think there's a lot more work that could be done to get us all on the same page in terms of environmental impact analysis. So we're going to talk a little bit more about this tomorrow, but we are at MII launching an environmental data coalition, EDC, where we want to bring together all the stakeholders in the industry to talk about environmental impact data, analysis, methodology, reporting, and decision-making, and what we can do to work together and collaborate to make this a more straightforward process. So stay tuned for more information on that. If you're interested, please reach out to us at MII, but we really are excited to be able to be the platform for which people can talk about this complex issue. While the Higg Index data I just showed mostly focuses on the beginning of life of materials, we also know end of life is something we really need to consider as well. A lot of the topics in the sessions today, I think, have talked about, well, is the material biodegradable? What are we going to do about it? And I think this kind of sets the stage. Currently, in the textile industry, almost 75% of all of our materials are being landfilled or incinerated. 30% of microplastic pollution is estimated to derive from textiles, and only 1% of all our textiles are recycled. So we know how critical the end-of-life problem is. And while many people think of this as something that's not tied to raw materials, the choices we make in raw materials inform what we can do at the end of life. So it is important for us to start considering how these new next-gen materials can fit into a system that manages the end of life as well. So I think a lot of people have heard the term circularity, and there's a lot of different definitions for what that means. But generally speaking, we want something where the economy is more circular, where we're minimizing the use of high impact inputs, allowing materials to re-enter the production cycle, or at least return safely to nature. So this is a really important white space, something I'll talk about later, that we are very encouraged by seeing a lot of next-gen innovators coming out with materials that are either compostable, biodegradable, recyclable, reusable, et cetera, that fit into this more ideal circular supply chain. So I've set the stage a little bit for why we need next-gen materials and why these technologies are important. I'm going to go into a little bit of how we at MII categorize and talk about the different technologies in the next-gen materials industry. First, I want to talk about material science. So I'm a material scientist, so this is a near and dear to my heart slide. If there's any other material scientists attending, they've probably seen this diagram before. It's kind of what you would see at Materials 101 class. But this is important for, I think, people to realize is when we're coming up with new materials, there's a lot of technological planning that needs to go into creating a material with optimal properties and performance. And really understanding that what we put into this material, its composition, as well as its structure and how it's assembled, are going to directly tie into the properties and the target performance you're trying to achieve. And it's really this loop, just like that circular economy diagram I just showed. All of these things impact one another. And so it's really critical for us to have the technological understanding, the scientific talent in this space to know if we're trying to replicate materials like leather or exceed them, we need to understand how all of these different aspects of material science fit together to make really good high-performing materials. And so just to highlight how complex this issue is, and it actually is quite a big challenge to replicate some of these animal materials, I've shown a diagram of a wool fiber. So this is a schematic where you're zooming in tiny, down to the nanometer level on a wool fiber. And you can see if you kind of break down the different hierarchical levels of the structure of the wool fiber, it's extremely complex. There's a lot that's going into it. It starts with the protein, right? The base materials that are going into comprising wool, which in this case is a keratin-based material. But how they're put together, how they're assembled is also really critical to the performance. So this is the thing that, is a huge challenge, I think, for the next gen materials industry, is that these animal materials are, they rely on not just what you're putting in, but how you bring them together. And so we're very encouraged to see that some of our innovators out there have made really great strides in this biomimicry approach to get not just composition, but the way we're putting materials together to get really high performance materials. So I apologize for this diagram being kind of small. It is in our State of the Industry report if you want to look at it in a bigger view. But this is, what we're really excited about. This is the conceptual landscape of how materials are currently being made in the next gen materials industry. For this diagram, I'm showing leather, but you could apply a similar diagram to our other categories: silk, wool, fur, down, exotic skins, etc. So as you can see, there's multiple approaches and multiple inputs that can come together to create a next gen leather. If we start at the top, we can see we have biomass. This is a very popular approach where people are taking plants, fungi, even algae, and we're taking either the waste or byproduct of agricultural industries, or in some case, growing brand new biomass, and we can convert that into the precursor materials that will create a next gen leather. So that might be you're growing an entire sheet like mycelium leather that was just talked about. You could be creating fibers. You could be creating the resin, binders, and coatings, or powders that go into making a formulation for next gen leather. But that category is really popular right now, really finding ways to create biomass. In the other side, we could use biotech-based approaches, which still might rely on biomass as a feedstock. But here we have microbes like yeast and bacteria that are functioning as little factories, essentially. And those little factories can output proteins, just like the protein I just mentioned, keratin for wool, or it could be collagen for leather, or it could be fibroin for silk. And we can also have biopolymers, which have very similar properties, things like bacterial cellulose. And these materials can then form those precursors that go into next gen leather. On the other side of the biotech spectrum, we actually heard a great presentation that went over this process earlier from Vitro Labs, is tissue engineering approaches. Here, you actually are taking cells from the living cow, a harmless biopsy that you take once, and you can grow those cells over and over on scaffolds to form basically lab-grown skin. Once you have that lab-grown skin, you can process it very similar to the skin of an animal to create next-gen leather. And then finally, in the middle, we also have some people that are taking recycled inputs. So this might be recycled plastics, it might be recycled textiles that are collected and converted into the components that can go into next-gen leather. So we're mostly sitting in the biosphere, but we do have a little bit of the technosphere from the recycled inputs as well. So from that complex landscape, we tried to simplify things a little bit at MII. And from that, we came up with 6 categories of main inputs that go into next-gen materials. So I'll briefly describe them, and in the following slides, I'm going to go into more detail on them. But we have plant-derived. These are materials that take virgin or waste plant matter and are using that as the main input. Just for simplicity's sake, we are also including algae and the fruiting body of fungi, which would be mushrooms, in this category, even though they're technically not plants. But for simplicity, we'll just call them plants. Mycelium is sort of a subcategory of plant-derived, but has grown in such popularity that we're giving it its own category. And this is actually the root-like structure of certain fungi species. If you were listening for the rest of the day, you've probably heard from Forager and from MycoWorks. There's a lot of activity in this space, and that's why we're giving its own category, because there's really a lot of interesting work going on in mycelium. We also have cultivated animal cells. This is the lab-grown leather tissue engineering approach that I mentioned, where you're taking animal cells, growing them in the laboratory to create skin constructs directly in the lab. Microbe-derived is the approach where you're basically taking acellular agriculture or fermentation processes. Again, this is where microbes are used as tiny factories to produce the components that go into a next-gen material. And then lastly, we have two categories, recycled and blended. Recycled is pretty straightforward. This is where recycled inputs are used as the main input. This might be plastic water bottles or textiles that go into making the material. And lastly, blends. Blends would be something where there's a mixture of components that aren't well captured by all of the categories we see here. So I'll go into a little bit more detail. First, a landscape overview of where these different categories are being utilized. You can see that the vast majority of our innovators that we've mapped to date, about 50% or more, are using plant-derived technologies. And then we have about 20% of them using the microbe-derived categories. So that's the next most popular. You can see that the remaining categories are a smaller share of the pie. This data is in our State of the Industry report if you're looking for more detail. And I will say that since we published that State of the Industry report, the landscape continues to grow and change, and we have a lot more innovators. So I would stay tuned to see how this pie chart is going to change for next year's report. So first, I want to talk a little bit about the plant matter feedstock category. Like I said, this is the most active category that we've seen to date. And here, basically low impact alternatives, products upcycled from agricultural waste or grown from renewable plants are the main input. And the interesting thing about this space is that we've seen, to date, compared to some of our other categories, it might be easier to scale these materials. There's abundance of raw material that people are relying on, and sometimes there's fewer technical challenges compared to things like the lab-grown biotech-based approaches. However, one of the challenges, and frankly, this is a challenge across the board, but it is one of the things that is persistent in the plant-based category, is that we're trying to find those binders, additives, and coatings that are free from petrochemicals, that are truly sustainable, and still be able to maintain the performance requirements that we need, things like durability and waterproofing. We're super encouraged to see that there's lots of innovators that are solving this issue, but I expect that we'll see even more in the future. I'm not going to go into a lot of detail on these examples because I think all of these players are going to be participating in the conference, so I'd encourage you to go to their talks and panels and to speak with them directly. But just a few examples would be natural fiber welding, their presentation earlier today. They have 100% bio-based, petrochemical-free leather material that they're working on called Mirum. Pinatex is a next-gen leather that has been around for quite a while, relying on pineapple leaf waste fibers. And they still do have the PU coating and PLA fibers in their formulation, but have really been successful in being implemented in a lot of different applications. Outside of leather, we actually see in the down category, one of our participants at the conference, Saltico, they're using wetland plants to create a next-gen down alternative. And then orange fiber is a next-gen silk, which is a cellulosic fiber derived from orange juice waste. So you can really see that this plant matter category goes across all of the different biomimicry categories that we are tracking. Next, mycelium. I'm, again, not going to go into a ton of detail because there's been some great presentations on this to date. But essentially, this is the root-like structure of fungi species. They're typically grown on renewable substrates, things like sawdust, in an indoor farming environment. And what's really fascinating about this material is that the mycelium forms a fibrous network that really mimics the collagen network of native cow leather, bovine leather. And as I think you've heard some of the players discuss today, because of this fibrous network and its similar structure, it can be tanned in a similar way to animal leather. And that enables it to have some of the similar aesthetics, such as coloring and smell and feel that we see in real animal leather. Again, getting away from petrochemical coatings is a challenge. And so that's something we're hoping to see continue to grow in this space. But most of the material, the vast majority of the material is completely bio-based. And because this is a brand new technology that's really only been created in the last few years, their scale up is going to require a lot of investment in farming and processing facilities. But we're seeing really fast movement in this space today. 3 big players in this space would include Bolt Threads, their Milo material, MycoWorks with their fine mycelium, and Ecovative's forager hides. All of these people are present at our conference, and we hope that you'll talk to them and learn more about their different materials. But we've already seen them in a lot of different product offerings, working with a lot of different brands. So it's a really exciting area. Next, we're talking about cellular agriculture. So here, these are cultivated animal cells. You can think of this very similar to lab-grown meat if you've been following the food industry. And here we have animal cells are being grown in the laboratory. Typically, these are on scaffolds, so something that supports the growth of the cells that are kind of in a soup-like bath. The cells grow, they form these tissue structures, specimens. In this case, it's going to replicate skin structure very similarly. If you saw the Vitro Labs presentation, they explained it really well. And the nice thing is that you basically then get raw skin as your output. And so again, you can, take this material, tan it, and get really similar properties to native leather. And this technique has probably one of the highest probabilities of really directly matching leather's properties because you're growing it directly from animal cells and replicating that structure really well. So it's a really exciting area. One issue in this space generally is because of this being really futuristic biotech approach, we still have high costs and complex process optimization. And those are the current challenges for those players to get to scale up and price parity. But again, I think it's happening really, really quickly. Costs are driving down constantly, and people are able to get their production at scale very soon. So just a few of the players, again, all present at the conference, Vitro Labs, Corium, and Faircraft. Please reach out to them if you'd like to learn more about their interesting approaches. But we're really excited to be able to buy this soon. So next is the microbe-derived category. If you recall, this is the second most active category. This is essentially using fermentation methods or cell culture methods, where microbes, typically bacteria or yeast, are the main culture organism. And they're creating, you're not actually using the cells in the final product, but you're using the cells to create an intermediate precursor material. So that might be proteins. So again, proteins are the building block of all animal materials. So if you can create collagen, if you can create silk fibroin, if you can create keratin, you're going to be able to mimic, the materials that we're looking for in the next gen material space. It's again a biotech-based approach, similar to the cultivated animal cell approach, in that R&D time and investment you really need a lot that goes into this in order for this to be successful. But we've already seen in other adjacent industries like medicine and food and cosmetics that we can deliver, high performance products at scale and at price parity. So we're really encouraged to see a lot of activity in this space. Just a few examples. We do have people creating collagen, like I mentioned, that would be Provenance Bio. So they're creating that collagen and then able to potentially convert that into leather. We've got people doing bioplastics. So New Light Technologies actually uses greenhouse gas inputs. So they're feeding the microbes methane and CO2 to create biodegradable plastics, a class of plastics called polyhydroxyalkanoates, which is a really long term. So we'll just call them PHAs. And they actually have an in-house brand called Covalent, which has created some leather products. So really interesting company. We then have a couple companies that are using bacterial cellulose. This is a really hot area at the moment, I'd say, in the microbe-derived space. We may give it its own category someday as we continue to see this growth. But your Bucha Bio is actually creating 100% bio-based leather from bacterial cellulose. I think you'll hear from them tomorrow. And Modern Synthesis has a unique approach where the genetically engineered organisms that they're using, they're actually able to have them not produce just the cellulose, but also the dye in the material. And so in this case, they're using melanin, which is what makes our skin be able to be tanned. And they're able to have then a black dye incorporated into the process. So pretty unique approach. And then we have Spiber, who's creating spider silk protein in order to make next-gen silk and a variety of other categories like wool and cashmere as well. Lastly, recycled materials. This is pretty straightforward, taking recycled inputs like water bottles or discarded textile waste and converting this. This is a relatively, straightforward process. The issue is sometimes getting recycled feedstock supply and the quality of that supply in order to be able to do this. And then some of the processing to get these materials to be high performance can be a challenge. We've got next gen down based on recycled polyester, next gen silk based on recycled textiles, and we've got von Holzhause's Technic leather, which is recycled polyester leather material. So lots of different players in this space. And then the blend category. Here, they typically combine a lot of things together. All of these are low impact input materials, so things like a plant-based, things like recycled material, and then there might still be some virgin petrochemicals mixed in. But these players are able to deliver at scale high performance solutions. Dynamica is a material that's been used in the automotive industry to date quite a lot. We've got House of Fluff, a next-gen fur company that uses DuPont Sorona. I think you'll hear from DuPont as well at the conference, which is a partially bio-based fiber. So there's a lot of interesting movements in this space. One of the issues with a lot of these blends is the end-of-life challenge can be even greater because of that material mix, right? You've got multiple materials going in at once. So making sure they're recyclable or biodegradable can be a big challenge. So I've just gone through a lot of those categories, and even while I was talking, I think I mentioned some of those challenges and opportunities. White spaces is what we call them, right? So these are areas where we need to draw more attention in the innovation space. And so I encourage you to look at our white space report if you're interested in learning more about what we've kind of identified as those hot spots that need a lot of attention. But a lot of it comes down to sustainability, right? We need the entire formulation to be sustainable. Resins and coatings, binders, dyes, finishes, these also need to have, sustainable inputs and processes associated with them. We need new fibers, we need new feedstock that is low impact in order to, really achieve our goal of sustainable materials. And so I encourage you to take a look at this report if you're interested to learn more of what we've identified as those kind of hotspots. And I just really like this quote from Dr. Amanda Parks at Pangaya. We're about progress over perfection. Innovation doesn't happen overnight, and we don't go from 0 to 100. There are steps to achieve along the way. And so we at MII are, really, we hope to be, rising tide lifts all boats. We're going to get through this together. We need collaboration in order to be successful. And I just wanted to point to one more resource kind of related to this white space analysis that I mentioned that we provide at MII. This is a disruptive textile innovation resources on our website. This is a list of basically interesting players in solution providers for those resins, those coatings, those dyes, those colorants, manufacturers, recovery and recycling solutions, things that we think can really help address some of the white spaces. We're trying to collect those innovators as well. And so you can find that on our website if you're interested. So I just want to remind everyone that this is a really nascent field of innovation. It's going to be a lot of progress happening over time. So stay tuned to see all the new and exciting technologies that are going to come out. Like I said, our State of the Industry report covers what we've seen as trends to date, but things have changed even in this first quarter since this report was published. Lots more players, lots more interesting investments are being made. So it's going to be a really, really great space. And just to remind you, fashion, automotive, and home goods are the key industries where we see next-gen materials being applied. And with that, I will open it up for questions if there's 1 minute left.
Thank you so much, Sydney. Well, since it's such a complicated topic, maybe what we'll do is encourage people to reach out to our team. So you've now heard from, two of our experts, Sydney and Elaine, and I'm sure people have questions. And that's the nice thing is we're here as a nonprofit to support the whole industry, and we would love to chat if we can help. So, head over to our booth or go to our website and you can find everybody's email. So please reach out. All right. Thank you so much, Sydney. And now we are actually at the end of the day, and I would like to bring a special guest, somebody very, very close to my heart. So,
hey, girl.
This is Stephanie Downs. Actually, MII was all her idea. She roped me into this like 2.5 years ago. And so I have to give her credit for absolutely everything that we've been able to do because it wouldn't have happened without her. And so we just have like 5 minutes if you'd like to
Yep.
stick around and hear, like, Stephanie's got an inspiring message for us.
Awesome. Great. Well, thank you so much, Nicole, and everybody. What an inspiring day this has been. Very exciting to see how far that has come in just a few short years. And I thought I'd actually wrap up today by telling the group a very important story about the idea of how MII came to be, which can all be traced back to something that you probably wouldn't expect, which is a hamburger. And I'm going to guess all of you have heard of companies like Impossible Foods and Beyond Meat. In a session earlier today, we made a correlation to the alternative protein industry. But I think it's important for everyone to understand how much we can learn from that industry to move next gen materials forward faster. As of 2015, veggie burgers and other alternative proteins had been around for decades, but unfortunately had very little adoption outside of vegans. New companies like Impossible Foods were starting to bring some products to market, but the list of innovators was short and the overall ecosystem was very small. And this is where Nicole and I met. We joined this industry at that time, back when vegan meat was definitely not cool yet. But because of some very strategic moves that were made in that industry, within a 4-year period, the landscape looked like this. I think it's worth repeating that this was 2015 and this was 2019. And this landscape can't even fit in it all of the dairy innovations that came out, which are, it's a whole other landscape in and of itself. So with that, I'm actually going to take my slides down. I'd love to invite Nicole to come back. Nicole and I were very fortunate. We got to be on the front lines with a small group of people in the alternative protein industry that drove that incredible transition. Nicole was part of a NGO in the food industry that had the same model as what we're doing with MII. They built the ecosystem that really brought that whole industry together. And because of that organization, I started a plant-based meat company that quickly became the largest plant-based meat company in India. And we went from idea to a nationwide launch across India because of a lot of the resources that we received from the ecosystem. So a few years ago, Nicole and I thought we could see that the animal materials industry was primed for the same disruption. So we decided to take the lessons that we learned there and apply them here. And then the number one lessons that I kind of wanted to leave this quick closing session with is that a rising tide lifts all boats. We really learned that in that space. We worked very collaboratively together. We helped each other out. And I think that really helped catapult us forward. So I think that this group that we have right here is in that boat or has the boats that are in the harbor. And I hope we will all help each other out and lift things up. And that's part of like some of the coalition that Sydney alluded to. But so happy that Nicole and I worked together to get this started.
Well, and so I'm going to call you out because you just totally like skipped over your major accomplishment, which does speak a lot to, what the Good Food Institute did for the industry and what we hope to do. So I'm going back to, the company you created in India. So I might misremember a little bit, but was it from concept to nationwide distribution in 18 months?
Yeah, R&D, forming the team, R&D, raising the funding, building a 25,000 square foot factory. So it was quite the ride.
Yeah. And then I think at the end you were at like, was it $1 million revenue a year, $1 million products sold?
Yeah. I think we sold 1 million products in the first 6 months or something. Yeah.
And so, I mean, when you've told me that story before, and I hope this will help everybody here as well, is it was because of that assistance you got from, the food industry nonprofit that helped connect you to investors, helped you identify that as a white space in India. And that's what we're hoping to do as well.
Yeah, no, and the Good Food Institute, the group you were with, I mean, they actually helped. They connected us to the first investors. It was incredible. Every time we ran into a challenge, we could pick up the phone, and also just the innovators in the space were really helpful to each other. I think Anila from Microtech was talking about that today. I mean, we really do. Let's all pull together because this market is huge. The animal materials industry, leather, wool, fur, silk. There's plenty of market share for all of us, and I think that if we work together and the brands and we all just we lift each other up, we will see this happen much faster.
Well, thank you so much, Stephanie.
Yeah. Well, thank
Really
you.
appreciate it. And thank you for bringing us all here. This all kicked off by you. So, okay, well, I hope everyone gets some great rest tonight. I know I'm exhausted, and we're going to have a very, interesting day tomorrow too. So I hope to see you all back then.